Unlock the power of creativity with generative AI. Join us on a journey to explore the world of artificial intelligence that can generate novel content and revolutionize various industries. From art to education, generative AI is changing the game by creating new and unique content that inspires and improves the work of artists and professors alike. In this video, we delve into the most popular generative AI models, their applications, and the incredible content they generate. Get ready to be amazed as we showcase the limitless possibilities of generative AI, from transforming text into video, to creating new and exciting artistic content. So, sit back, relax and join us on a journey to discover the future of creativity with generative AI. Introduction. Generative AI is a branch of artificial intelligence that is designed to create novel content, as opposed to just analyzing or acting on existing data like traditional expert systems. The primary difference between the two is that expert systems relied on knowledge bases and an inference engine that generated content through a set of if-else rules. On the other hand, modern generative AI models make use of a discriminator or transformer model that is trained on a large corpus or data set. This allows the model to map input information into a high-dimensional space, which is then used by a generator model to create new content. In this video, we will provide a review of the most popular generative AI models, focusing on their applications and the content they generate. We will also provide a taxonomy of these models, and analyze each of the categories in detail. Finally, we will conclude with a discussion of the implications of generative AI for various industries, as well as suggestions for further work in this field. Our goal is to provide information for professionals working in industries that can benefit from these models, and to inspire the creation of new and innovative applications of generative AI. 2 Generative AI Models Categories. 2.1 Text-to-text models. Text-to-text conversion is an important aspect of artificial intelligence, particularly in tasks related to general question and answering. There are 4 popular models that are specifically designed to treat text and output text to cater to a variety of needs. These models are specifically designed to take input in the form of text and generate new, relevant text as an output. 2.1.1 ChatGPT. ChatGPT is a conversational model developed by OpenAI, designed to interact with people in a natural and intuitive way. This model is well known for its ability to answer follow-up questions, correct incorrect information, and reject inappropriate requests. The technology behind ChatGPT is based on a transformer model, but with an added twist. The model was trained using reinforcement learning with human feedback, which means that the initial training was done by having human AI trainers provide sample conversations. These trainers played both the user and AI assistant roles and provided their responses to the model-generated responses. The data collected from these human trainers was combined with data from the InstructGPT model and transformed into a dialogue format. If you're interested in learning more about ChatGPT, you can find a demo of the model on the OpenAI website, along with information on how to access the API. Additionally, there is a summary of the training process on the ChatGPT demo website. Lastly, it's worth mentioning that ChatGPT is also capable of generating code and simple mathematical expressions. 2.1.2 LaMBDA. LaMBDA is a type of language model designed specifically for dialogue applications. Unlike many other language models, LaMBDA was trained using dialogue data, which makes it specialized in handling dialogue. It is a transformer-based neural language model, which means it uses the latest technology in AI to handle text data. LaMBDA has the potential to have up to 137 billion parameters and was pre-trained on 1.56 trillion words of public dialogue data and web text. This pre-training allows the model to have a general understanding of language and conversation before being fine-tuned for specific applications. During fine-tuning, the model can be adjusted to ensure its responses are safe and based on factual information. One of the strengths of LaMBDA is its ability to perform multiple tasks with a single model. It can generate several responses, which are then filtered for safety, grounded on external knowledge, and re-rank to find the highest quality response. This makes LaMBDA highly versatile and capable of handling a wide range of dialogue tasks. LaMBDA is a specialized language model for dialogue applications that utilizes the latest AI technology to handle text data. With its large size and pre-training on massive amounts of data, LaMBDA has the potential to provide high-quality responses for various dialogue tasks. 2.1.3 Peer. Peer is a collaborative language model developed by LaMBDA Research that is designed to help people with the writing process. It is based on a four-step approach: plan, edit, explain, and repeat. The idea behind Peer is to break down the task of writing a paper into smaller, easier subtasks that can be tackled one by one. This makes the writing process much simpler and less overwhelming. Peer is mainly trained on Wikipedia edit histories, which gives it a good understanding of how text is written and revised. The training process uses a self-training approach, where models are used to fill in missing data, and then other models are trained on this synthetic data. However, this approach has some downsides, as comments on Wikipedia can be very noisy and there is a lack of citations. To try and compensate for this, Peer uses a retrieval system to find additional information. However, this system doesn't always work, so the model can still be limited in what it can do. The process of using Peer involves iterating through the four steps multiple times until the text is in a satisfactory state. At any point during the process, a human can intervene and steer the model in a different direction if needed. This gives the user complete control over the writing process and ensures that the final product is exactly what they want. The Deep Speed Transformer is used for training Peer, which is a powerful tool for machine learning models. This allows Peer to be highly scalable and effective, making it a great choice for anyone who wants to simplify the writing process and improve the quality of their text. 2.1.4 LaMBDA Speech from Brain. LaMBDA Speech from Brain is a model developed by LaMBDA that aims to help people who are unable to communicate through speech, typing, or gestures. In the past, techniques for communicating with people who are unable to speak relied on invasive brain recording techniques that required neurosurgical interventions. However, this new model attempts to decode language directly from non-invasive brain recordings, which could provide a safer and more scalable solution for a wider range of people. The main challenge with this approach is the noise and differences in each person's brain and the placement of the sensors. The model was trained using a deep learning model with contrastive learning and Wave 2 VEC 2.0, a self-supervised learning model. This was done to identify the complex representations of speech in the brains of volunteers listening to audiobooks. The two non-invasive technologies used to measure brain activity were electroencephalography, EEG, and magnetoencephalography, MEG. The training data came from 4 open-source data sets, which represented 150 hours of recordings from 169 volunteers listening to audiobooks. EEG and MEG recordings were inserted into a brain model, which consisted of a standard deep convolutional network with residual connections. This allowed the model to have both a speech model for sound and a brain model for MEG data. The results showed that several components of the algorithm were beneficial for decoding performance. As well, analysis showed that the algorithm improved as EEG and MEG recordings increased. This research demonstrates that self-supervised trained AI can decode perceived speech despite noise and variability in the data. The biggest limitation of this research is that it only focuses on speech perception, and the ultimate goal would be to extend this work to speech production.